Is it possible for you to write on the board? Okay, that's good. So try to write here number 5. When an aqueous solution of ammonium sulfate is combined with an aqueous solution of barium nitrate, a precipitate is produced. So you write a balanced molecular equation for that. You start with ammonium sulfate. What are you using to write? Oh, I thought it was a pen. You should use a pen. It will be faster. You should write a molecular equation, not the charge. Not ionic yet. Yeah. You click the arrow back. So you can click this. Yeah, that one. Ammonium sulfate. The charges would become the subscript. So what's the charge of SO4? Yeah, so that would become the subscript of ammonium. Yeah. Then combined with aqueous solution of barium nitrate. Alright. These are reactants. So what will be the product? Yeah, you forgot the product. So okay. Barium. What was that? Barium nitrate. You wrote phosphate. This one. Yeah, you take note of that. Okay. NO3, nitrate, barium. Okay, so you do displacement. So barium would pair with sulfate. So there'll be barium. What's the charge of sulfate? -2 and barium +2. So that would become barium sulfate. the charges cancel out. But this one, barium, you don't have this one. For barium nitrate, you don't have a subscript here, because for nitrate the charge is -1. So it should be barium BaNO3 2 and barium sulfate. Then you'll be left with, what will be left here? If we pair barium and sulfate, you have ammonium nitrate. So you have ammonium, you write ammonium plus 2 nitrate is minus, so NH4NO3. NO3's charge is -1, so you don't need subscript, so only NH4NO3. Then we balance that. Yeah, you start with nitrogen, so nitrogen there is 2, and you check the nitrogen on the product side. Yeah, nitrogen here, 2 atoms of nitrogen, so that means we also have 2 here. Yeah, so you put 2 here. The next is hydrogen. Oh, you already have 2 there. NH4 2 and oh, you have another nitrogen here, that's 2, so it's 4, so you put 2 here, so it will be 4. And then next is hydrogen. Hydrogen is 8, right? 4 atoms times, okay, 2 is 8, so let's check here if hydrogen is 8, so it's already 8, so it's balanced. Then let's check barium. Barium here is 1 atom also on the product side, so you don't need to balance that. You don't need to, yeah. So we only added 2 here in front of ammonium nitrate. So this is the molecular balance equation. Then next is you write the total ionic equation. So this is the molecular equation. Yes, I can hear you. Can you do the full ionic equation? You just split like what we did in the previous equation. Split the ions. Split all soluble ionic compounds. So which one here is the precipitate? Precipitate is barium sulfate. Yeah, alright. So you won't split that, only those soluble ionic compounds. NH4 plus. Okay, so you have 2. Take note, the subscript of ammonium is 2, so you put here 2 moles of NH4 plus. You do like that. Yeah, so you put the charge. What's the charge? Here, -2 plus 2 minus. You should put the charge. This one, you have to split that one. Ammonium nitrate. You don't, remember, you don't split when it's a precipitate, when it's solid. So you just leave it as it is. What is the charge of nitrate? Okay. Yeah. That is the full ionic equation. So NH4, let me check, SO4 minus 2, barium plus 2, 2NO3, BeSO4. Yeah, you did it correctly. Except this one, you forgot. Hold on. Then it's 2, yeah, this one. Then that one is the full ionic equation, and now you need the net ionic equation. You cancel the spectator ions. Spectator ions, the same as in like algebra, like the common. Which one there? That would cancel out. Okay, so cancel that. Cancel that. What else? This one? Yeah. Yes. You forgot that here. Except barium sulfate. Then you write the full net ionic equation. You canceled. I already scratched them out. Those spectator ions. No. The cancelled, this is the full ionic equation. Then the green one, when I cancel them, those are the spectator ions. Whatever is left, that one is the ionic equation. Okay, so can you write the... Okay. So you got a, what's your score? Almost 100? Wow. Congrats. That's good. Okay. Then you write the net ionic. Are you going to have an exam on this? Oh. Yeah. So you have to put the state aqueous and solid. Okay. Now, do you understand how to do it? Yeah, you have to know the formula of the compound. You have to know how to write it and the charges, the polyatomic ions. Alright, you want to, let's try number 6. Number 6 is, give the balanced chemical equation for the neutralization reaction that occurs when an aqueous solution of HCl is combined with an aqueous solution of barium hydroxide. Okay, let me cover it with this one blank. No, I just, can you hear me well now? Okay. Then, okay, neutralization reaction that occurs when an aqueous solution of hydrochloric acid. So it says hydrochloric acid and what's that? Barium hydroxide. So you write the balanced molecular equation. Okay, HCl plus barium hydroxide. What is the charge of barium? Yeah, so it should be 2. Barium chloride. Yeah. Okay. And then plus it's water. Yeah. So H2O. So H2O liquid. Aqueous. Okay. So we don't include water. No, because it doesn't say, there's no solid here because it didn't say there a precipitate is produced. It says neutralization reaction. So you balance. Okay, everything is correct except you balance it. You start with hydrogen here. You have 2 here and 1, so 3. So you have 2 here. So you can make it 4. Yeah, you put 2 here, so in the reactant side you have 4 hydrogen, so you should have 4 in the product side. Okay, I think that one is already balanced. Then you write the full ionic equation. You split everything except the liquid and solid. So we have water there as liquid. Yeah, that one is the molecular balance equation. Then you need to write the full ionic equation. Full ionic is you split all of the ions. Alright, can you still hear me? Okay. Yes, you have to write the state. OH is -1. Mhm. Yeah, except the liquid and solid. Mhm. So you have, okay, 2H plus, yeah, 2H plus, Cl minus,
then barium 2, where is that? Okay, barium 2, and then 2OH. Where's your 2OH? Yeah, but then you only wrote OH. Yeah, and then B8 plus 2Cl. Oh no, this one you need to split because that one is not solid. So that is Ba plus 2, then 2Cl minus. You need to split this one. Yeah, that one. BaCl plus 2Cl minus. So you have two atoms of chlorine there. Alright, so we already have that 2HCl. Then the next is you cancel the spectator ions. Yeah. So this one is the molecular balanced molecular equation. This one is the full ionic equation. Then when you cancel out the spectator ions, that would be your net ionic ion. How come your chlorine is? Oh, you forgot your chlorine here. Cl. You have 2 chlorine here, supposedly. So you have 2 HCl from the original equation. So only the barium and chlorine cancel out. So you'll be left with hydrogen, OH, and water.
At least now you know how to do it, right? Okay, so that one is correct. Let me check here. I checked the next page. What's this? Give the full balance chemical equations to represent if any combinations would give no reaction, write no reaction. Yeah. Okay, wanna do this? Okay. Reaction between HBr and potassium hydroxide. Can you write that? Reaction between HBr and potassium hydroxide. So this is a strong acid, strong base, because bromic acid and potassium hydroxide. So this is neutralization. So HBr plus, what is potassium hydroxide? Okay, KOH. Neutralization. KBr. Yeah, potassium bromide. Yeah, so you should write the states. No, this is aqueous, potassium bromide. I think it's, yeah, I think it's still aqueous. Liquid. Yeah, that one is correct. I think it's Wadi balance. And for letter B, reaction between sulfuric acid and sodium hydroxide. No, you don't need, because you're only asked to write the full balanced chemical equation, not the ionic equation. When it asks you for the ionic, so you write the charges. Sulfuric acid plus sodium hydroxide. Okay. What's that? Na. Mm-hmm. Yeah, what are the subscript? Don't forget the subscript, because sodium sulfate is Na plus then sulfate. So it should be Na2SO4. Yeah? You have one hydrogen, so that's H2O. No. So you must balance it. It's aqueous. Mm-hmm. Alright, that's correct. Yeah, so that one is Wadi balance. Yeah, you got it. Yeah? At least you're the one doing it. Yeah. So you can practice. Then for letter C, the reaction between calcium hydroxide and H3PO4. What is H3PO4? Uh, phosphoric acid. Oh, I see. Let's see. Mm-hmm. H3PO4. Okay. Calcium and phosphate. Yes, that's correct. Yeah, that's right. Where's your 2 for PO4? PO4 2. It's H2O. Yeah, where would you get H4O? H2O. Yeah, it seems like you're inventing H2O, and then you just do like, you add like 2 moles. But okay, now you need to balance that one. You start with the first element, calcium. Mm-hmm. Number 3 should be 2 H3PO4. 6. So this one is, yeah, this one is 2. And then your hydrogen, how many hydrogen there? 6 plus 6, 12. So you should put 6 here. So now it's balanced. Okay, we move on to the calculation. Number 8. No questions on ionic equations. Go back. Where? Okay. What volume or 0. What's that? What happened to my pen? 0.0937 molar H3PO4 is needed to neutralize 25.0 ml of 0.108 molar barium hydroxide. So you get the volume of H3PO4. So yeah, we start with 25 ml, but you can write the balance equation first. Because you need the mole fraction. Or maybe we don't need the mole. Yeah, we need the mole fraction for that. So you need a balance equation. Yeah, plus barium. Mm-hmm. Okay. Maybe you also again think H4O. Mm-hmm. Mm-hmm. H3, BaHOH2, PO4. Oh, you forgot this one. And then you balance. So that is 2 here, right? And 3. Ba. Because you have 3 here. Ba3PO4. And then your water. Water is 6. 12. Yeah. So 2 H2PO4, 3 BaOH2. Okay, that's now balanced. Then we start with we get the number of moles of barium hydroxide from the molarity. So 25 ml. 25 ml times 0.108 mole per liter. Yeah, barium hydroxide. I know mole per liter, so you convert this to 1000 milliliters. So what is the value there? Wait. Then point. What's the answer? 0027. 0027 mole barium hydroxide. And then we use this number of moles then to get the number of moles of phosphoric acid. Phosphate. Yeah, phosphoric acid. So from here 0.0027 mole barium hydroxide times the mole ratio. Mole ratio is 2 moles of H3PO4 per 3 moles of barium hydroxide. That's why you need to write your balance equation. If your equation is wrong, then all of your calculations will be wrong. Okay, can you calculate that? Mm. 2 divided by 3. .0018. Okay, mole H3PO4. Then can I delete this one, the one above on top? Okay, from there, then we can calculate the volume because we are asked for the volume, right? Volume of, okay, we're given the molarity, so we just multiply that or divide 0.018 mole H3PO4 divided by 0.0937 mole per liter H3PO4. So the answer should be liter H3PO4. Then we convert that to ml. So what is the answer? You divide 0.0018 by 0.0937. Now can you hear me? Hello? 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 Oh, can you hear me? No, you divide. So you cancel the moles, the mole unit, and you'll be left with liter. Yeah, 0.0018 divided by 0.0937. Okay, so that, and then you convert that to milliliters times 1000. So that is 19.2. Okay, then that should be the volume of H3PO4. Now you know. The camera is strange. There's something. Okay. For the rest of the problems, can we do it? Yeah, your next lesson will be next Friday, Thursday. That's quite far. And you're gonna have. Can we do it on our next lesson? Or maybe if you have time, you can schedule it. Okay. All right, Ali, do you have questions? Yeah, at least you now know how to write the balance equations, but you have to take note of the charges. Then the full ionic, not ionic, and this one. All right. Okay, you're welcome. You have a great night.